All right, for example 2, it says determine an appropriate viewing rectangle for the function f of x equals the square root of 8 minus 2x squared, and use it to graph f. Now this one here, they don't give us options for the viewing rectangle. They just leave it up to us to figure it out. All right, and that happens sometimes. First off, anytime you want to graph anything, you start going to the y equals, go to your input place here to input the function. Typing in a square root, so hit second and then x squared, so right above the x squared you see the square root symbol. Above the, let's see, there's not like a cube root or something, that's in the math menu, just in case you need to do it. Hit math, that would be for any root, that's a cube root, and that's for any other root. Right there, the x root, that kind of stuff. But I think right now we're going to stick mainly to square roots if they happen. So. And if you do go on the math menu, if you choose anything, it'll take you right back where you were. Otherwise, you can hit y equals to get back where we were. Now, this calculator, again, different from the other calculators. Last time you did get a square root, put a parentheses there. You type in what you want, end parentheses. This one, it keeps the bar over top of everything underneath the square root. So 8 minus 2x squared. You can see everything in the expressions underneath the bar. If you hit to the right, that gets you out of the square root and finishes it off. All right, so if there was other stuff after that, that's how you get out of the square root. Just tap to the right arrow key there, and get you out. So you're not inside the square root sign anymore. Now, as far as graphing an unknown window, the place I start at is the standard viewing window. That's negative 10 to 10. If you hit the zoom button, it's the third button over on the bottom here. You see all these choices here. Number 6 is zoom standard. That's just negative 10 to 10 on x, negative 10 to 10 on y. And that's a basic good starting point. Usually graphs are in there somewhere. Okay, it's not perfect. Okay? But it's in there somewhere. Now, what I want you to do on a problem like this, I want you to draw me a picture of your first graph that you got. And I would say basically I would start a standard every time. Just give me the negative 10 to 10 look for x and y. And then zero in on the right, on the good graph, what you consider to be good, and then give that to me for the final answer. So I would first of all draw this rectangle, negative 10, 10, negative 10, 10, x-axis, y-axis. And then the graph looks like it goes up to about 3, goes left and right about 2, so I would kind of sneak it in right there. So that's kind of what it looks like. Of course, the one on my calculator screen is a little bit prettier than the one I drew on my paper, which will probably be the same case for all of you. But again, give me your starting point. This is where I started at. Now, looking at this standard viewing window, I can see the graph lives completely above the x-axis. It doesn't look like it goes much beyond negative 2 or 2, but it might go to negative 2 and 2. It doesn't seem to go above 3 either. Now, what I want you to do, I want to capture the entire graph, but I want to get as much of it as I can. So what I'm going to do is I'm going to go from negative 3 to positive 3 and from negative 1 up to 4. Okay, so I'm going above, below, left, and right. So the graph I'm looking for is going to be inside that box. So negative 3, 3 on x, negative 1, 4 on y. Hit graph again. And that gives me a better, clearer view of what's going on. Still looks like it's completely above the x-axis. Looks to me like it might touch at negative 2 and positive 2. Looks to me like it goes up to about 2.8 or 9, somewhere in there. All right, that could be your finished answer right there. That looks perfectly fine to me. The entire graph's there. Okay, do we think it touches at negative 2 and 2?
No, it doesn't.
Okay, what's the y value at negative 2 and 2? All right, I should say, what's the y value when it touches the x-axis? Let's go that route.
Well, it doesn't touch.
But if it were to touch, what would the, when it touches the x-axis, what's the y value?
1 point.
What's 8 letter day?
0.
0. If you're on the x-axis, the y value is 0, right? Okay. Can this thing here equal 0? All right, let's try it out. If x equals 2, what's 2 squared? 2 squared, 4. 4 times 2?
8.
8 minus 8?
0.
0. So 2 comma 0, and negative 2 squared is positive 4 times 2 is 8 minus 8 is 0. negative 2 and 2 are supposed to touch the x-axis. It doesn't look like it touches, but maybe it does. Here's how your calculator works, going back to this window. It picks next value on this scale here, on this delta x here. So at negative 3, it goes up by this much each time. So it might pick negative 2.000001, and then might pick negative 1.9999997, and then it skipped over negative 2. It didn't pick that number. All right, that's what that's how your calculator thinks. All right, so know that your graph, even though it doesn't look like it touches, it really would touch. All right, that's up to you to determine when you're drawing your picture. You know, if you pick it poorly, it might like get the first point might be right here somewhere, and then all of a sudden it only graphs to right here. That wouldn't be a very good graph. So you might want to monkey with the numbers a little bit more to get closer. But again, for me, that looks pretty good. That looks like what it should look like. So there's my initial viewing window. The constraints that got me the best picture in my mind were those.
You mean negative 4 on the bottom?
Negative 1 up to positive 4.
It is
Yeah, negative 1. That's what we put in, right? And my scale was 1 on everything. You can see scale 1, so that's another one. If you know what your scale is, down 1, 1, 2, 3, 4 up, 1, 2, 3 over, 1, 2, 3 over. So you can use that scale to count off where you're at also after you're done graphing.